In our study of calculus, there are basically two main concepts that we learn throughout the course. Today, we're going to develop the first of those two main concepts. Before we develop it, we're going to look at the tangent line problem that existed with early mathematicians that they could not really solve until calculus was developed. To get an understanding of this tangent line problem, let's figure out some characteristics of tangent lines. So what do we mean when we say that a line is tangent to a curve at a point? Okay, so we're going to have to go back to geometry and think about what tangent lines were. So let's start with a basic geometry shape. Let's say we had a circle, because that's usually how we looked at tangents. And we want to know, well, what's the tangent at this point, P? Well, a tangent is a line that intersects a circle at exactly one point. Now in a circle, there's only one way you can intersect a line at one point. And that's if you're on outside of the circle and you barely touch it. So there's a couple of concepts that we have. A tangent line intersects a circle at one point. Okay. Now another thing we can say about this tangent line is that it is perpendicular to the radial line at point P. So when we say radial line, that means if I were to take the center and sketch in the radius, so you have an infinite number of radius, but we're talking about exactly that one radius, then this radius and the tangent line are perpendicular to each other. So a tangent line is perpendicular to the radial line at point P. Then the other thing we can notice is, and I stated this earlier, but notice that the tangent line is all on one side of the circle, specifically outside the circle. So that's another thing we learned back in geometry. A tangent line lies on one side of a circle. Good. Now, if all we had to do was deal with circles, then we probably wouldn't have a tangent line problem. Because from a circle, we could probably get the equation of that tangent line depending on where it is in the circle. But what if, instead of having a circle, we have some random curve? So let's look at what happens then. So let's talk about a tangent line to a curve at a point. So for this particular situation, let's say we have some random f of x. So here's f of x. And we choose some point P, and we want the tangent to that. Okay, well, let's see here. Take my ruler. draw my tangent line. So here is my tangent. Alright, well, when we look at a tangent to a curve, what we do is we only take a small little section of this. And then all of these previous concepts apply. So notice, does it intersect the curve at one point? Now when you only look at this little area, it does. It only intersects the curve in one point at that little portion. Now it does intersect later on, but when we talk about curves, it's okay if it intersects later on, but as long as it only intersects one point at that little section, we're okay. It's perpendicular to a radial, so there is some radius out here, and it's perpendicular to that, and it's all on one side of the curve. Now again, that's only here, because it does go on the other side down here, but we're only interested in this little side of the curve. Okay, now the issue we want to figure out, this tangent line problem, is we want the equation of the tangent line. So how do we find the equation of this tangent line? How do we find the equation of this tangent line? Alright, so just to review, to find the equation of any line, you need a point and you need a slope. So usually the point's not too bad because we're going to be able to figure out what the value of that point is by getting the x value and the y value. But we also need the slope of this tangent line, and that's where the issue comes in. So to find the tangent at a point P, this was a question up here, we first need to find the slope of the tangent at point P. So we need to find the slope of this tangent line. One thing that I just noticed is I just said tangent this time, and so when somebody says, well, what's the tangent, they do mean tangent line. That's kind of in it, but if you also say tangent line, that is okay.